Hi guys, in this video I'm going to run you through everything you need to know about differentiation from first principles for A-level maths. Every section has been timestamped so you can easily jump to a section or rewatch it if you need to. Hope this helps. Differentiation calculates the gradient of a curve. We first learn about the concept of gradient when studying straight lines. Straight lines have the property that their gradient is constant. In other words, for each unit we increment along x, y changes by the same amount. Curves don't share this property. As we can see on this curve, moving the point on the left of the curve along the x-axis changes the value of y less than it does for the point on the right. The gradient of a curve at any point is given by the gradient of the tangent at that point, and changes as we move along the curve. Differentiation gives us a formula for the gradient at any point on the curve. We call it the first derivative, and we notate it as dy by dx or f dash of x. Differentiation from first principles is how we calculate the first derivative with no prior knowledge of calculus. Let's remind ourselves we are trying to calculate the gradient of the tangent at any point on the curve. We have a problem because in order to calculate the gradient of our tangent, we need 2 points, but we only have one to work with. Let's leave the tangent alone for a moment and take another point a distance h along the x-axis and consider the chord that connects these 2 points. The run between these 2 points would be h, and the rise would be f of x plus h minus f of x. The gradient of this chord would then be f of x plus h minus f of x all over h. Now notice, as we decrease the value of h and bring the points closer together, our chord becomes the tangent at our initial point. This process of decreasing h to 0 is called taking a limit, and it gives us a formula for the first derivative of a function. Before we apply our new formula, let's recap the basics of function notation. Consider the basic function f of x equals x squared. In this notation, f denotes the function and x the input. This function simply takes the input and squares it to produce the output. Now let's change the input to x plus 2 and apply the same function. F still just squares the input, so f of x plus 2 would simply be x plus 2 all squared. For A-level maths, we need to be able to apply the first principles formula to powers of x up to x cubed, as well as sine of x and cosine of x. Let's start by applying the formula to f of x equals x squared. As f of x is a squared function, f of x plus h is x plus h all squared. Now let's substitute f of x plus h and f of x into our formula. We immediately encounter a problem in that we have h in the denominator, so it seems as though we need to evaluate division by 0, which is undefined. Let's ignore that for a minute and instead expand the bracket in the numerator. From here, we can cancel the x squared terms. All the remaining terms in our numerator now have a factor of h, so we can cancel one factor of h from the top and bottom. Now we can see that our expression leaves 2x in the limit that h tends to 0. Next, let's apply the first principle's formula to f of x equals sine of x. F of x plus h in this case is sine of x plus h, as we have changed the input of our sine function from just x to x plus h. We have the same problem as the previous example where h is in the denominator, so we need to manipulate our fraction before we can take the limit. To do this, we apply the sine addition formula from the formula booklet to sine of x plus h. Now let's substitute this result into our fraction. Next, let's split up the fraction into 3 separate fractions and reorder them. We can factorize out sine x from the first 2 fractions and cos x from the last fraction. Whenever the differentiation from first principles of cosine or sine of x is asked in your exam, these two limits will be provided. Using these two results, we can see that the final result for our limit is just cosine of x. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.